Ignition sequence starts.
The world is in constant change and development. All fields of life have progressed. Connection between humans, work and shopping. Travel and movement, even fun and games. Everything in people's lives runs now through smart devices, connected to a vast digital space. Humanity reached their scientific peak only through a long journey of creativity and contributions, which the Islamic Arab civilization was part of it. Through the development of various sciences, atop of them is mathematics, which paved the way to humanity to probe the depths of life and travel to space. Through smart programs based on algorithms, attributed to the great mathematician, the genius, father of computer, Muhammad ibn Musa al-Khwarizmi.
Baghdad was the capital, it was the center. It was the seat of governance, it was the center for trade, if you like, the sort of economics, and it also became, in a way, the scientific center.
Baghdad was the capital of the world, the metropolis of life. Every knowledge seeker wished to go to Baghdad to receive lessons from scholars with great influence. In addition, the Abbasid caliphs had great interest in building schools. This quantum leap in science made a significant impression on knowledge seekers. So they started researching and studying during the peak of Caliphs Harun al-Rashid and al-Mamun's reigns.
To such an extent that any scholar who wrote or translated any book from any language to Arabic was paid the weight of it in gold or silver.
Everybody who was ambitious, everybody who had a story to tell, everybody who had a talent and so on, would want to come to Baghdad. That's where the jobs were, that's where the caliphal court was, as it were. Be on the world stage, then you left wherever you were born and brought up and you came to Baghdad.
Under the rise and power of the Abbasid Caliphate, one of the financially abled families emigrated from a town called Khwarizm in the Khorasan region on the outskirts of the Islamic State, heading to the heart and center of the Caliphate. That family settled in Kurtabal near Baghdad. Among the members of that family grew a very smart, distinguished and bright young man who was observant, passionate about research, science and knowledge. He is Muhammad ibn Musa al-Khwarizmi. Al-Khwarizmi lived his youth in Kurtabal, where he used to spend his days either among scholars or in the family farms, helping his family in cultivating and caring for them. Al-Khwarizmi was very confused, as his mind was always occupied with measuring distances and learning volumes. Each body his eyes observed would immediately turn into lines, drawing geometric shapes.
Peace be with you.
Peace and God's mercy and blessings be upon you.
You look busy and distracted, Muhammad.
As long as I'm awake, I find myself occupied with the shapes of things and the distances between them, calculating their heights. Moreover, I find myself busy, connecting imaginary lines, from a palm tree to the other, from a tree to a tree, from a house to a house, to an extent that my head is filled with intersected lines and various geometric shapes, imaginations and images accompanying me during my wake and following me in my dreams while sleeping.
My son, if I'm guessing correct, you will excel in mathematics. So go to Baghdad to seek knowledge, and do not waste your time on farming fields, lest your energy go to waste.
But I help my father in farming and I can't...
Go to the House of Wisdom in Baghdad. I am sure you will find what you seek. And leave farming to farmers. As for your father, leave him to me.
Thank you, my dear teacher.
May God bless you.
Peace be upon you.
Peace be upon you too.
Al-Khwarizmi was no longer confused, and his sheikh's words ignited his enthusiasm. He headed towards Baghdad, the world's metropolis at the time of the peak of Islamic glory, seeking knowledge.
Al-Khwarizmi enrolled in the House of Wisdom, which at that time was the center of science and scholars. It was established by Caliph Harun al-Rashid, who dedicated a huge budget to it, due to his love for science and scholars.
The Dar al-Hikmah, the House of Wisdom, was an institution of the government. It used to be thought that this was like a university, that it had professors and classrooms and that sort of education.
And it started as a center for learning about philosophy, literature, and the sciences from wherever it could be found. And so the sources were Greek sources, so people were sent to Greece. The sources were Persian, so a lot of Persian sources came in, and there were a lot of Indian sources.
If we would picture the situation during Al-Khwarizmi's age, there was no internet, not even printed books. And in order to learn anything, one needed either to meet a scholar in person or read the manuscript someone manually copied in a science or a field of knowledge.
Of course, Al-Khwarizmi benefited from studying in the House of Wisdom, as there were prominent scholars in his days who translated works from other civilizations.
This scientific atmosphere played an essential role in Al-Khwarizmi's works.
Amazingly, Al-Khwarizmi, having a bright and sharp mind, managed to receive a license to teach mathematics in only 2 years, the thing that none of his peers achieved at that time.
His teacher praised him to the Caliph Harun al-Rashid, who asked the teacher, saying, "Didn't you have a skilled, successful student in mathematics?" The teacher answered, "Yes, I have Muhammad ibn Musa al-Khwarizmi."
Caliph Harun al-Rashid knew that knowledge is power, not a luxury. He encouraged smart students, provided them with the appropriate environment, and took good care of al-Khwarizmi, who devoted himself to books, one after the other, reading, criticizing, and extracting useful information, until al-Ma'mun's reign, who facilitated for al-Khwarizmi the means to continue his journey in research and learning by appointing him the secretary of the Caliph's palace books treasury.
Thus, he put under his supervision huge scientific books, whether in Persian, Turkish, or Arabic, in addition to the fourth language he had learned, which was Greek, thus adding his scientific weight. Al-Khwarizmi at that time read many books on mathematics.
These equations are still complicated.
I agree with you, Abu Jafar.
Let's review this part from... What's that noise? What's happening?
It's okay, Abu Jafar. Don't worry. It seems some laymen have come to ask the scholars about matters such as renting,
Things became hard for us.
dividing shares, quotas, zakat, almsgiving, etc.
Oh, scholars of Baghdad, what should we do? Only Allah cares for us. What is the proper quota? Things became hard for us. Only Allah cares for us.
There's no good in science that won't help people. And there's no good in scholars isolated behind walls from people.
Al-Khwarizmi's, unlike so many scientists, but even today, it's just the most kind of wonderful example of today what we might call popular science. He really understood how to communicate to audiences who are not expert and for making his information and knowledge relevant, and that's something that I think we can all learn from.
An Islamic scholar needs accurate numbers regarding fields like taxing, zakat, renting, and trade in general.
The necessity from the Sharia aspect also called for his action. So, he would serve Muslims concerning inheritance issues. We're talking about the Abbasid Caliphate, which at that time expanded to nearly 40 Islamic countries. And many people from those countries converted to Islam, and they were totally ignorant about the inheritance, science, and its process.
Muhammad ibn Musa al-Khwarizmi conquered mathematics, which was scattered between unrelated, unorganized numbers.
Actually, at that time, mathematics was suffering a lot, for it was difficult to deal with numbers. There were no symbols for numbers in mathematics. The Greeks used Latin letters for symbols, and Arabs in return referred to numbers with the letters corresponding to them.
Before Al-Khwarizmi, how were numbers calculated? It was very difficult to deal with numbers, especially by laymen. If we take a look at an example of those numbers, or the Roman symbols, we'll know that these symbols, the numbering process depended on letters like these, or symbols as such. These symbols were very difficult to deal with. They were useless in calculations, even in simple ones, and not apt for improvement. Let's imagine how people did calculations. We'll find that it was a very, very difficult and complex process. How would a Roman student calculate 26 by 14? 26 was written as XX, meaning 10 and 10. Then 6 as V, which is 5, and then I, which is 1. 14 was written as X and V, which is 5, but I was added in front of it, meaning this is 4, not 6. If we want to multiply them, what do? We write 26 14 times like this, and add it to itself. This is, of course, a very difficult and a very long process. And after that, there was a kind of calculations by sentences. They started making tables like these, and specified in them a number for each letter, meaning A is number so-and-so, it can be thus and it can be such. According to the letter arrangement theory, which is Arabic literal notation, Abjad, Hawaz, Hati, Kalman. At that time, someone made a joke. One of the princes died. So, he wanted to document the date of his death. He wrote Fe al-Meshmesh, in the apricot, meaning that letter F equals number 80 in the table, whereas I equals 10. A is 1, then he started collecting them, taking each number corresponding to each letter, thus reaching the result that the prince died in the year 801, which was actually true. But this process has a very high degree of difficulty, especially in other calculations. All this was before al-Khwarizmi.
At that time, al-Khwarizmi started searching for knowledge everywhere. His mind was occupied by Indian arithmetic process, as Indian scholars had excelled in mathematics inventions and science.
Al-Khwarizmi noticed that Indians used symbols for numbers, and he managed to develop these symbols, which became the Arabic numerals, now forming them based on angles.
Numbers after al-Khwarizmi, as we see in this table, depend on angles. Thus, we can say that this number 1 is the Arabic number 1. This is the Arabic numeral. It's based on one angle. Concerning number 2, he defined it with 2 angles, whereas number 3, he defined it with 3 angles like this, and so on until he reached number 9, which he defined it with 9 angles. As we can see, 1, 2, 3, and here is 4. Here are 5, 6, 7, 8, 9. These are the angles that defined the number. These are the Arabic numerals.
Khwarizmi learned this Indian arithmetic. He understood how important it is, and that it's a game changer in calculations. But it only had 9 symbols from 1 to 9. So I still might face a problem with a number like 601. I'm going to write 1 in the odd numbers column and 6 in the hundreds. But what am I going to write in the even numbers column?
Today, we know it is the 0. We just simply put 0 in the even numbers column. Back in time, before al-Khwarizmi, in different civilizations, this dot was somehow mysterious.
They used it in ancient civilizations, separating between numbers, and they shaped it like a hole. They would pierce the writing, shape a hole, thus representing separation and not value. So al-Khwarizmi was the only one who added the 0 to this system, creating a major development in numbers.
When Khwarizmi added 0 as a place value. So we have, for example, number 1, add 0 to its right, and it will be 10. Add 2 zeros to its right, then the number will be 100, and its multiplications. This solved a major problem. Thus, Khwarizmi managed to deal with numbers.
وقام كاتب كتاب
He wrote a book explaining Indian arithmetic. And through it, people learned about mathematics, which lasted till today. Not the book itself, but the process of calculations. This is what we use today. And we're able to write any number, no matter how big. And we perform calculations following the algorithmic way. By algorithmic way, we mean a set of sequential and simple steps leading to the result in a very simple way.
Al-Khwarizmi played a significant role when he wrote the book on the Indian arithmetic. He explained the importance of zero, establishing an important pillar in mathematics. Setting zero was one of the milestones. He managed to reach a set of knowledge. The majority of civilizations before that, each one was still operating, to some extent, independently. He had such intelligence and brilliance, which enabled him to extract and deduce from this knowledge its useful aspects, and then paraphrase it. I mean, he didn't just pass it, rather he took advantage of it, fully comprehended its meaning, and then formulating it in a simple and useful way.
Al-Khwarizmi's belief in science had no limits. He didn't stop at solving mathematical problems. He was ahead of his age, writing the jewels of his works, and which became a milestone in the history of science. It was destined to be one of the cornerstones of modern mathematics. As he wrote his founding book, the compendious Book on Calculation by Completion and Balancing.
الكتاب المختصر في حساب الجبر والمقابلة, which is his book on algebra. Literally every school child in every country that goes through school uses this book, even though it's not necessarily acknowledged.
The book on calculation by completion and balancing was written by Al-Khwarizmi, where he stated the basics of algebra, one of the most important branches of mathematics today. These basics were founded on the idea that there is something called equations. These equations may form a relation combining between certain numbers.
Al-Khwarizmi's most important achievements related to mathematics is the compendious book on calculation by completion and balancing, equations that had two sides. So he would transmit this negative part and move it to the other side. Algebra is transmitting fractions, squares and roots from one end to the other, whereas balancing is simply adding similar sides, which no one thought about before. How can I take this 5x and this 3x, and through algebra I transmit it to the other side? 5x added to 3x equals 8x. He based his title on this concept, completion and balancing.
You'll find that Al-Khwarizmi's book describes and categorizes equations, which no one did before. Then he set methods to solve these equations based on specific arithmetic steps.
There is an actual proof that each part leads to the next one, reaching to a final correct answer. An idea that, when computers were invented, with their high ability to calculate fast, they were programmed through algorithms, named after Al-Khwarizmi. Al-Khwarizmi himself didn't write algorithms in the way we use today, the way of thinking.
This linguistic influence proves how Al-Khwarizmi's books on algebra and mathematics influenced the minds and ideas of the modern European civilization.
After Allah's guidance to aid to write the book on calculation by completion and balancing, I thought of making a compendious for it, so people would use it in their everyday lives, thus facilitating for them the matters of dividing inheritance, calculating trade, and measuring space. I seek reward from Allah only, for my success comes only from Allah. On Him I have relied. and he is the Lord of the Great Throne.
Muhammad ibn Musa al-Khwarizmi left a useful legacy, represented in a collection of books, treatises, deductions, and over 20 to 30 books.
Khwarizmi published some research papers. Nowadays, how does science advance? Some researchers send specific works to be published, which we call them papers or lectures. This work may consist of 4 or 5 papers addressing a certain problem. For example, he had solutions for sundial. He also published research papers on astronomical calculations for the 5 moons known at that time, and on the movement of stars and planets. He also managed to mathematically calculate them, thus becoming the actual founder of the Islamic astronomy.
Al-Khwarizmi died in 223 AH, 847 CE.
After a while, his 2 major works in mathematics, the book on calculation by completion and balancing, and his book on Indian arithmetic, were translated into Latin.
Some of Khwarizmi's work only survives in Latin translations. The original Arabic has been lost. So it's a profound impact on Western intellectual culture. And then a lot of his texts and a lot of other Arabic astronomical and other texts were printed very early on, when printing becomes widespread in the 16th century.
Fibonacci, the Italian scientist, a contemporary scientist, meaning he came around 200 years or more after Khwarizmi, was born and raised in northwest Africa, then moved to Italy and studied Khwarizmi's books. He transferred the term zero into Italian, calling it Zafiro, which was passed later to the French and was called zero in English. The word zero in English originated from the Arabic sifir.
Islamic civilization embraced mathematics, and Muslims excelled in its branches, enriching scientific life with great contributions. Despite the development of the Islamic civilization witnessed during the past centuries, Al-Khwarizmi's books remained as the foundation stone upon which the modern scientific civilization was built.
The Western civilization kept using the decimal system and still use algebra today. Algebra is a major branch in mathematics, surpassing the equation stage founded by Al-Khwarizmi, and it is still called algebra, and still leads many modern global algebra books, which were just published a year or 2 ago. It is said that the origin of this book goes back to Al-Jabr wal Muqabala book on calculation by completion and balancing. Certainly, the role of mathematics on all fields, whether on the internet, or the stock exchange, or on an ATM machine, they wouldn't have existed if it was not for the great development in mathematics based on what was founded by Al-Khwarizmi.
There's no good in science that won't help people, and there's no good in scholars isolated from people behind walls.